Okay, look at this question. It says the capacitance of a parallel plate capacitor when in air is 3 microfarad, and in the presence of a dielectric material 6 microfarad. The dielectric constant is, I repeat, the capacitance of a parallel plate capacitor when in air is 3 microfarad, and in the presence of a dielectric material 6 microfarad full stop. The dielectric constant is, so how do you know this? First of all, solution. What is the formula of capacitance to start with? C equals to dielectric A over D. Is that correct? Okay. And now, what do they say here? Capacitance of a parallel plate. Before we go into that, because they said when in air and in the presence of a dielectric material, when in air is 3 microfarad, that is for this. You get now? So what do we do then? What do we do? What do we do? Now, what we need to do is multiply both sides by 1 over EO. 1 over what? EO. When we do that, we're going to have 1 over dielectric times C. That is the capacitance, times C over 1 equal to EO over 1. That is A times 1 over EO. When we do that, here we are going to have C over EO equal to A over D. Here is D, not 1. Because this one now is going to cancel out with this, right? So we're going to have A over D equal to C over EO. That is dielectric. Having known that, now, when in air, it is 3 microfarad, right? When in air, it is 3 microfarad. So what do we do then? Give me a marker. So A over D equal to capacitance over this. So what we do then? So this is equal to 3 times 10 raised to the power minus 6 over, what is our EO? Unknown. Right? Good. Now, when that is A over D, here now we're going to say in the presence of dielectric material, in the presence of dielectric material, in the presence of the electric material, it is 6 microfarad. What I want you to understand that here, this thing was like 3 microfarad equals to this over D. Close this window, this sound, close it. So now, likewise here, but what do we do then? Close this side. So what do we do here? Using the same formula that we used over there, D equal to, because they said here now, the dielectric constant was to C over this, right? Over what? EO, or we say R, whichever one. This is dielectric constant or permittivity of a medium. Is that correct? And this is equal to, the C here is what? 6 times 10 raised power minus 6 over this, right? And that is A over D. So right now, what we have here is we have this 3 times 10 raised power minus 6 over EO, which is equal to 6 times 10 raised power minus 6 over this. Is that correct? Huh? Is that correct? Now, we are looking for, because we are asked to find the what? Ratio. We are asked to find the what? So the ratio is going to be this over this, and which is going to be 6 times 10 raised power minus 6 over 3 times 10 raised power minus 6, because if you cross multiply this thing now, from here, this thing now is EO times this, right? And from here, this is ER times this. Is that correct?
Yes.
So this symbol is equal to, this is 3 here, 1, 3, and 6 divided by 3 will give us 2. So what we have here is 2 over 1. Now, mathematically, this thing now means ER ratio EO, which is equals to 2 ratio 1. Is that correct? Is that correct?
Yes.
So now, since it is 2 ratio 1, and this 2 ratio 1 means 2 over 1. So 2 divided by 1 will give us equal to 2. Our answer here is C. Did you understand? You don't understand? Now look up. They said the capacitance of a parallel plate capacitor when in air is 3 microfarad. As is to say that this has 3 microfarad, but they say when this thing now is 3 microfarad when it is in air. But what you are being asked to find is this permittivity. But you are not given the figure, or should I say the value for the value of permittivity. Do you understand now? This A and D, we don't still have the value here. So they are just constant here because you don't need them. That is why we use this mathematical method through the way of what is it called? Subject formula, to get our EO, because this A over D means area over what? Distance, right? So parallel plate capacitor when in air is, and in the presence of a dielectric material 6 microfarad, the dielectric constant is, there's no provision for area, neither is there any provision for distance. But the question was straight. It was specific on dielectric constant. That is why we apply mathematics here to exempt capacitance and dielectric constant, or should I say permittivity of either medium or free space, or whichever one we are being asked in the question. Did you understand now? So we did that when it was in air. And when it was in air, we were told that permittivity of a medium also means permittivity of a free space. Now, what do you understand by a free space? We have permittivity of a medium. We have permittivity of a free space, or it's a vacuum. We also have relative permittivity of a what? There are 3. We have this. we have ER, we have EO, and we have E, right? Huh? So that is why it was asked in this question, in the presence of a dielectric material, 6 microfarad, the dielectric constant is, huh? The dielectric constant is, that is what we are being asked to do or to find. Did you understand now? Huh? Do you understand now? So the dielectric constant is what now? So since that we don't have stops, we don't have area and distance, our focus is on capacitance and the permittivity of either free space, vacuum, free space, medium, or dielectric constant itself. Did you understand now? So that is that.